right, how are we doing? Great. Working set model. Some operating systems do actually use this. The idea is we're going to look at a set of page references, maybe the past 10,000 instructions, and see if we can basically come up with any information from there to come up with a better paging policy. So you're going to have your delta as your working window, for example, 10,000 instructions. If it's too small, maybe it will not get all the locality of what's happening. If it's too large, you might have too many localities, so to speak. And if it's infinite, of course, it encompasses the entire program, which is not exactly what we want. D is the sum of all your working sets, so all your deltas, all total demand frames. And if it's greater than M, you're going to have some sort of thrashing. So what you want is, if D is greater than M, then suspend one of the processes, is the idea. Here's a picture. On the left, what's the working set of this delta? Well, it's 1, 2, 5, 6, 7, because those are the pages that were referenced. While over here is just 3 and 4, because those were all the pages that were referenced. The idea or the assumption is, hopefully if your working set only had this at this point in time, hopefully in the future it will only have that as well. So how do you keep track of a working set? Well, literally every delta instructions, you interrupt the process, swap it out, and then keep in memory 2 bits for each page. One was, of course, the reference, and then make that part of the working set. Why is this not completely accurate? Well, it doesn't go back possibly as far. And then, so what you could do is have 10 bits and interrupt every 1,000 units to actually get a little more resolution of what's going on. But the problem here is you're interrupting your process to do memory analysis of the past. The idea of the frame or the working set is, after a while you'll come up with an acceptable page fault rate, and you'll decide what that number should be. If it's too low, the process is going to lose some frames, and we'll give those frames to other processes. If it's too high, we're going to try and get some frames from someone else, or if there's no frames to get, then we're going to suspend the process and allow someone else to run, because we're going to say that that process is thrashing. Let's see, page fault rate over time. All right, I don't know if I understand what they're saying with this one. All right, any questions on the working set? It's just a method to try and deal with thrashing. I said earlier, most of the time is ignored. Okay, I lied. Because I think Windows actually does working set, if I recall correctly. Working set, good. All right, memory mapped. The idea here is you'll have a piece of memory that literally reads and writes are the same as reading and writing to a file. That's all it is. So instead of doing read and write system calls, you are reading and writing straight to a file. This allows multiple processes to actually read and write to the same file, so memory mapped I/O. This can make it a lot simpler for different processes, and also that means that the operating system can actually optimize it, because it can be buffering all your memory and make sure it gets written to disk when something actually occurs. All right. Memory map file, everyone makes sense? Everyone sees what it's doing? Windows does this just like shared memory. Probably is how every operating system does this. All right.